Hi everybody. Alright, I got this motor block off of eBay a couple days back. It's a opposed twin 18 horsepower Briggs & Stratton block. And my goal is originally it was an internal combustion engine. Well, my goal is to make it, I say engine, internal combustion motor, power converter, because it's not an engine. It doesn't generate anything. It just converts one form of power into another. But anyhow, so what I'm going to do is I'm going to build this thing up. I'm going to take out the original valves and valve arrangement entirely out of both sides of this. And I'm going to hook it up so it's got external pressure to it. Now, for the purpose of experimentation, I will start off with compressed air. That's the only thing I have at the moment. Later on, I will go ahead and I will get some stainless steel coils I have, and I will build a boiler so that I can boil water and drive it with steam. And then later than that, eventually I hope to get a certain specific Kalina cycle ammonia motor out of Minnesota down here and use it. And this is mostly proof of concept. This isn't like by any means a really efficient. I've got a far more efficient design I'd like to build, but it requires a lot more complex machining that I'm not really set up to do yet. And even though I hypothetically could do it, it would I don't know, I might try it, but I would kind of like to see about having a friend of mine do some of the complex machining on some parts. But either way, whether I do it or they do it, it's going to be I'm going to build a different motor or power converter, what do you want to call it. I just tried to wash a lot of the grime off of it. I got a lot of it off, but not all of it. And the cylinders are a little damaged. I got it off eBay. It was kind of a known to be damaged thing. I'm spraying this stuff. It's perfumey. It's supposed to be for hair clippers. It's a hair clipper lubricant. I suppose it's called Cool Care. Never heard of it before. And it smells kind of like, it says on here, for clipper blades. Is that at a good angle? Anyhow. So it's for clipper blades on, I guess for beauticians, cosmetologists, what you call it, people that, I got it because it's supposed to both clean and keep off water and prevent corrosion. Now I know I just sprayed some on, and I'll wipe it off and then spray some more on. And that's because I'm trying to see how if I can remove any more grime with it, and or if I can be sure I've removed all the water, even though I did use a rag and kind of wipe that down. Then it's not really critical if it's just minor rust, because I'll have to line bore it to make certain it's completely clean. But I just want to spray a little of this stuff on here just to kind of see how well it works. I guess I could have sprayed one side with WD-40 and one side with this stuff and seen how it did, but I'm pretty used to WD-40 and how it works, so I'm just going to see how this stuff does. See, and make certain I got a good coating of it on there, because I've never used it before. I don't know how well it coats, but it almost has the effect of dry silicone lubricant, which is good stuff. If it's dry silicone lube, I'm going to look it up. If it is, I'm going to get the rest of it, because they had a couple more cans of it on sale. Because dry silicone lube is just good stuff. all the way around. They say it cleans, and well, I don't know. I'm spritzing a little bit. No wonder it's been around a long time. I didn't know they had it. Maybe they had it in the back. Anyhow, the cap just crumbled. I don't know if it's wiping up the oil any better or old grease on inside here better than just wiping it with a dry rag, but it's taking some off. I don't know. I've never seen it before. Didn't know they had it. Don't know why a hardware store would have something like this, unless it was supposedly also for farm supply. Again, it's got perfume to it, so it kind of smells more like something you'd see in a salon than anything. It's been around. The caps are so old. They just, yeah, it's been around a while. Now I got cap particles to pick up off the floor. Anyhow, so this device, what I plan on doing is I'm going to have the cylinders, of course, as with any opposed. You wouldn't really want them to swap back and forth. I don't know if they would do that or not, but I wouldn't, even though they say, yeah, well, that makes it so that it's got power at 90 degrees. Well, this thing is going to be essentially what you'd call a one-stroke motor now instead of four-stroke. So what that means is that instead of it firing every fourth stroke, it's going to fire every stroke. So I'm going to valve it with pressure to the internal chamber and fire pressure to the heads. And that wouldn't really work if you had them opposed to each other like this, because you'd always have pressure in the middle, which would defeat the purpose. But if you have it where you've got pressure blowing out and then pressure blowing in, then it works perfectly fine. And since, of course, it comes originally with a cam, I'll be cutting this whole area right here off and drilling it out so that I have enough room for really big high flow valving. What I'll actually have in the head a pair of plug valves that go through here. That there'll be a valve. The pressure will come in here, and this valving system here will be able to both inlet pressure on one stage. When this is up and outwards, pressure will come into the cylinder, and when it's inwards, pressure will go out of the cylinder. And since the first two are just going to be expendable, the compressed air will be expendable, and then the steam will be expendable. So I won't worry about recapturing the actual exhaust gases. But when I get to the cleaner cycle, which is ammonia, then it'll be a closed loop. Now, one thing, it won't matter for compressed air that this has vent fins on it. That won't bother it any. It will bother it for steam. So what I will be doing when I get to the point where there's steam is I will put some kind of foam material in here and literally fill the radiators up with foam. Or ceramic or something. I will solidify that so that it's not radiating heat. Now somebody says, yeah, it'll still radiate some heat. I just don't particularly want to go to the effort to grind those off and then foam it, because I have to foam it either way. And sure, it'll be a little less efficient that way. Now with ammonia, it won't be as critical because the ammonia will be coming through dry, technically. It may have a little moisture and there may be a little condensation, in which case there'll be a drain in the block to handle any water, ammonium hydroxide that builds up. This area right here will probably, because it'll probably sit this side down, and this side, plus it'll probably still have to have some kind of oil pan. Although problem with using steam is when I've got steam is your oil will flub up real bad. You know, it'll turn motor mayonnaise on you with steam. It's a guarantee. In fact, for steam, I'll pretty much have to insulate the whole block. I might just go ahead and after I build the plumbing, build a box around the whole thing except the output shaft, fill the whole thing up with foam. Because if I don't want the foam there for any reason, I can take it off with a wire wheel, or just all sorts of ways. I can take it off with, you know, a wire wheel would be best, but a knife or whatever, just blast off the foam if I want to. Again, this is purely experimental, and that's the only reason I got it, was to experiment with it. So really, that's all that really matters, is that it's 2 opposed cylinders where I can have the pressure here and a relief here. My valving, I'll have a set of valves that comes in here that will valve into the block one way and into the head the other direction. And at the same time, the cam, I'll have another valve probably on this end that is timed off the same cam. So the valve to the exhaust will be shut when the valve to the internal, the central power will have to be open while the central exhaust will be shut. And so I'm thinking about maybe having a thing's called a hypoid bevel cam, but anyway, it's the swash plate cam, so that it draws it in and out. And I have to either have that built by one of my friends, or I'll have to build it myself. But the idea is that it'll have the cam will rotate the valve in and out this direction, while this valve in here will slide back and forth. And the idea is there'll be a valve it'll be a big spool valve, and there'll be some holes cut, and I'll probably have to weld or epoxy some pieces in here to go through, because I just want to essentially line bore right through from this valve seat area straight through these holes. And even though I can cap that off, in fact I can put the power outlet, I'll have to cap these off, which is no big deal, just screw a piece of metal on there, that's no big deal. In between here, where there's not any real, there's no real blockage in there per se, I'm going to have to probably drill a hole and put a tube through it. In fact, I may put a steel tube, and might even, I don't know if they'll fit, I haven't removed these valves that are in here, but I might just use something like a piece of bored out 1-inch steel pipe, which I have some. Let me see if I can get a little piece and test fit that. This, I believe, is 1-inch. I'm pretty sure this is 1-inch pipe. So I could probably get that. It doesn't matter if I got in this way, but I can probably get that through here. Because, yeah, if I can drill a hole all the way through here and just seat that pipe through here, and then put a spool valve, I just mill a spool valve to fit inside that, then all I have to do is just bore a hole right through here all the way through. I don't have to patch anything. I cut a hole. In fact, I could literally set this up on the mill, take the mill and open it up in here, and it'll just go right through, and that'll take care of it. And any gappage in here, I'll just, if it's in the way, I can TIG weld it, put a little aluminum in there and weld that shut. And then these, I'm not worried about, but I can weld them shut if I need to. But if I just drive a pipe through there and it seals up, because this thing won't be used again as an internal combustion engine, so I'm not worried about destroying the block. I'll be destroying the block as far as an internal combustion motor goes, and I know it. But I knew that before I got into this project. That was part of the plan. And as far as cam timing, it'll probably be 1-to-1, and I'll be building my own crankshaft, And in fact, hang on a second here. I can make another one of these, and from what I can tell from the diameter of that piece of metal and looking at the difference of the block, that's a pretty good size. Just drill another one of these out and put one on in the middle, and well, one on each side. And as far as steel shaft goes, if I'm really desperate, I can turn this thing down. After all, this has been welded and turned. This was cut in two. Then I welded it and turned it. No, I didn't. I forgot. I threaded it. I couldn't take it off by hand. But this is actually threaded on here. I can take it off with a pair of pipe wrenches. I think. Depends on how strong I am. I get weak. I've been weak for a while, but I might be able to take that off of there. If not, oh well, you're not missing anything. I can get it off with bigger pipe wrenches if nothing else. Where's the other? There's another pipe wrench. Okay, there's the pipe wrench. Let's just see if we can get this off of here. Ow! Ah, hurt my wrist. Stinking old wrist. So, yeah, I can use this for part of the crankshaft. It's threaded pretty big. In fact, technically, I'm not sure where I'm aimed at now. Technically, if I want to, it may not be advisable, but since this is purely experimental, it really doesn't matter. But I mean, it's just something I could do if I needed to. And if I really wanted to get crazy, if I needed a flywheel desperately, I can just chuck this up in the lathe and cut the, it's even got some kind of factory lathe mark. I don't know if it's visible on here. I can't even see the thing myself, but anyhow, it's really hard to see, but there's a little cut mark in here from the factory, and that may just be where it was welded. But if I needed to, I could cut that thing down to a balanced amount of mass, because obviously otherwise it'd flop all over being an eccentric like that. But I could make that into a flywheel, and if you think about it, with that being external and this being internal, I could, I don't know, I'd have to dial that down. It's a little too big, but anyhow, and I don't know how big the plate in here is, but I could do that if I needed to. And I don't know what I'm going to do. It's just an idea that I've decided to do. And I'll get parts, but I'll probably just make a couple more plates like this to make the crankshaft with. And like I say, the one in the middle will have 2 hulls, and the one on each side will have 1 hull, and it'll be probably press fit together, interference fit. You're just playing it by ear though. I'm gonna have to make my own pistons and my own connecting rods and everything. And also, I'm gonna make them fairly light. For 2 reasons. One, they don't have to be very heavy. Realistically, for what I'm doing, there's not gonna be in a position to output a lot of power. The other is because the material I can get a hold of, I can get a hold of thinner material quicker than I can thicker material. Now, as far as getting whether I use steel or aluminum, I don't know. I've got steel I could use, but I think I could probably get some aluminum plate pretty cheap. In fact, I think I could probably get my friend up in Minnesota to cut me some connecting rods pretty cheap. And then as far as the actual pistons, I think what I want to use is PVC for the first time around. Hang on. I've had this one adapter bushing from PVC plumbing stuff. It's like 3" to 1.5 or whatever it is. I don't know if it would fit here or not. I've never tried it before. I'd have to turn it down a little bit. It's pretty thick walled though. I think I'd still have a... But anyhow, I think I could make a piston out of something like this. And it's not super heavy. Or I could just resin cast a piston. You don't want them super heavy. So if I can cast it out of polymer resin, I've got some regular Bondo resin. It's cheap. And I could even use Bondo body filler, you know, and just make something really lightweight and cast it into a form that fits just in there. As far as compression rings, not a big deal really. As far as making a tight seal, if I was desperate for a tight seal, I think what I would do is I'd put a little groove in it. A very small groove in it, and which I'd turn on a lathe probably, and then I'd stick a rubber band over it. And I know that some rubber bands will turn brittle and break if you put them in there, but some rubber bands are made, or O-rings are made of Viton and or other type rubbers that are more resistant to oil and stuff. I can use some kind of cheap material. I got this rubber, which is kind of a gaskety rubber, and it's been exposed to gasoline and stuff, and it's still pliable. It's even swelled up and shrunk back down. It's a little firmer and a little less originally springy, but it would do the job. And if you just took a piece of this on top and then put it, like say if you had a piston and a cap, I know this is a really bad example, but sandwich it between a little lid of a small big piece. I don't know, I mean, hang on a minute, maybe put a piece of plastic lid of some kind. I've got a lot of different plastic lids. Maybe use plastic lid for the basic diameter if it's the right size. Let me see if I can find one. Now, in a way, this is a bad example because obviously it's already too big to fit the cylinder, even though I do have to kind of bore that out a little bit, just a teeny bit to clean it or hone it. But anyhow, just find a plastic lid that would match the diameter of the piston, and like this is a little larger than it has to be because it's got those traction ridges on it that you use to grab it, turn them off of there, and it's a smooth surface. Some lids are already smooth surfaces. I could see using a metal lid, I suppose. Again, mainly because just the size, and then it would give a kind of a clean surface. I don't know if this lid's a good size or not. It's probably too small. A little too small, yeah. And this lid's too small. But, you know, I just experiment, fool around with something until I find a device that's... Let's see if this cottage cheese container fits. Huh. Might use a cottage cheese container and use it for a piston. It'd make a good form. It's a little tapered, but it'd make a good form, I think. It's a little domed like a hemispherical piston, but that's really not important either, because we're not worried about compression ratios or any of that. But one thing about it is the cottage cheese containers come in really uniform sizes. Yeah, I just saw that around there. I thought I'd look. That's the thing for extending dryer hoses. So anyhow, I can find something somewhere that I'm not going to use my paint gun, but I just had to see if, you know, thankfully for me, no temptation there. It's too small. So I'll find some object like a cottage cheese container and rig it up to make a piston out of it, cast it, mill it, drill it. See, because of the low power, I don't need a really super perfect pin through it, so I can just drill it. I've got pin material. I've got straight bar stock in different diameters. This is a larger one I've got, and it's literally too big because it's too heavy for this job. Because again, I want to make it light. But I got smaller bar stock, and technically I even have rebar, which if I can get a straight piece out of that. So basically, my whole thing is I can make lightweight pistons for this thing pretty easy out of something. And it really doesn't matter that they have temperature resistance. And the temperature is really unimportant because it's really never going to get that high. Let me see if these fit. A little big. Huh. I might make a good mold. Put some mold release on that, and I could mold a piston pretty close to the size. I've got several of these, so if I screw up, I've got a few more. As long as I get the mold done properly, then, you know, if I lose a couple cups making them, then that's not such a big deal. I may even have a steel can. I doubt it though. Yeah. Let me put these away real quick. by all means, there's bound to be something that makes a good fit. Just thought I'd, you know, it's round, see if it fits. A tuna fish can. Huh. It's a little sloppy. If I can find something acceptable to wrap around the edge of it, that tuna fish can would make a pretty decent piston, I think, all things considered. I might do that. I might use that. I don't know. But casting it a little more dimensionally correct still kind of has an appeal to me. Just, I don't know, it just depends. Using that has some advantages and some disadvantages. Anything has advantages and disadvantages. But generally speaking, though, that would make a decent little piston with some kind of, especially if I had a Teflon material that I could cast on the front of it. If I could put some kind of Teflon or non-stick sealable compressible material in here that would slip just in there, like an oil impregnated Teflon or an oil impregnated polyethylene or some kind of coating, I'll have to look into it. Something I could just stick to the surface of that. Then I just put a little bitty, almost like a plumber strap, not a plumber strap, electrical strap. Don't think I have any in here. Well, either way, or I could find some little something or another's to stick in there. Not these, they're not balanced, and they've got little metal nuts made on them, but just made me think, that's why I was saying of something like a plumber strap. But either way, if I like drilled and put a aluminum plate through there and some screws or something, I don't know. We'll fiddle it around, and again, the idea is to make the pistons as light as possible, because they don't need to be. They ain't never going to see more than maybe 150 psi tops. So, and that's in fact, my compressor now only runs at 135 in theory, even though because the transducer's 135 pound transducer. So, but either way, as long as that has a good decent seal without too much friction, and I've got a decent flywheel on it, it should go ahead and rotate adequately to open and close the valves. And they only have to open and close a little bit, really, because the amount of flow is going to be higher than the compressor can put forward. So it'll take a lot of it'll take a lot of inertia to and I've got some brake drums from my mom's car that were left over that make great flywheels. In fact, I could put one on each side. Not that I need one on each side, but it just makes it a little more balanced for the load on the crankshaft, as far as having the load that way on each end of the crankshaft. But not important. And again, since all of it's internal, with pressure blowing in, no sparks. As far as timing advancement, yeah, you could advance the timing on the valves, and you could even do it by an internal cam, so that if you had a little lever that you could use to kind of throttle it a little bit, at the same time you'd throttle the airflow or fluid flow, we'll say air because it could be steam, ammonia, even water technically, although water would be pretty sloppy. Water would give you a good solid displacement, but boy, it wouldn't be an easy thing to run through this. You know, this kind of, you know, piston operated devices in this case are never really good with liquids like they are with gases. But be that all as it may, the whole point is that with a small valve that I can adjust both the flow and the timing at the same time. My big rotary valve, which is good for like 600 horsepower, if I had a way to use it on anything, I mean, I run massive 4-foot cylinders with it. I mean, not 4 foot in diameter, but well, 4 inches in diameter, but or maybe even that diameter, but still they're 4 feet long, and you know, it'll flow enough gas to make them run. But that's only, of course, if you have enough pressure going upside of it, because it's good for 10,000 psi, and so, you know, 10,000 psi of steam or ammonia pressure on a 4-foot crank journal would be, if it were a 4x4 cylinder and you said 78.8 or 16, it'd be around 12 and a quarter square inches times 10,000 psi, be 12,000 pounds at 4 feet would be, actually 4 feet would be a 24-inch throw. So it'd be 24 times 12,000, which would be 144 12 12s is 144 doubled over, be 288,000 foot-pounds of torque, which even at a very slow RPM would still be a whole lot of torque and a whole lot of horsepower. But still, that's immaterial to what we're doing right now. I'd be lucky to get 1 horsepower out of this. In fact, the compressor is only rated for like 2.6 horsepower, and with power losses and everything, I figure I'd get about a quarter horsepower using air on this. Steam, since I'm only limited by the conversion rate, and I've got a 1-inch 600 psi stainless steel tube, well, and then whatever plumbing between there and here, because the plumbing's got to handle whatever pressure the rest of it can. But you know, I mean, depending on how you fed the steam engine, because you'd have to have a pump on there to make certain that, you know, the pump would have to be driven actually off of this device, because the pressure would be higher than the water coming out. Otherwise, you'd be limited to like 80 psi or whatever. Which 80 psi on here, I'd say you're talking 480 pounds of maybe cylinder pressure times maybe 2-inch stroke would be, we'll say with losses, about 900 inch-pounds, which if you divide that down by a foot, you divide it by 6, would be it'd be 150 foot-pounds, hypothetically. And then it'd be based on volume and our, you know, revolutions per minute at that. And of course, remembering that you're going to fall off both because of production losses, you know, thermal kinetics, you know, the faster it boils, the faster it cools. You start having that tapering unless you've just got an unbelievably hot flame. And then on this side, because of parasitic losses, your flow and everything like that, the higher the RPM, naturally, just like any system with valves and everything, you start running into limits with that start to cut you back on total speed and everything. So your power's going to taper, your torque's going to taper off as your RPMs go up till you reach whatever. I would say that I would be very impressed if I got 1,000 RPM out of this. I'd be honest. I'd be honest with you. I'd be amazed to get 1,000 RPM on this, especially with a head of 80 psi of steam. I'd be happy to get 2 RPM with compressed air. I'd be happy to get 2 RPM with compressed air at even 135 psi, because it wouldn't last but a couple revolutions. That'd be it. In fact, I'd probably regulate this down to 20 psi, just enough to literally make it turn over. No load. No attempt to put a load on it with compressed air, because I don't have enough compressed air. Now I could, like I say, I can get enough steam if I can get enough fire into the coils that I have. In fact, I can enhance the coils I have by putting fins on them, thermal conductive fins that increase the total amount of heat they absorb out of the firebox. And again, because I can put a blower on there, I've got electric blowers, or I could eventually put a fan on there if I wanted to make it an integral system. But then also I can put a really high PSI pump on this thing. I've even got a pressure washer pump that's good for 2600 PSI. So I mean, I could put all sorts of pressure on it if the system wasn't going to blow up on me. That system, those pipes, I've tested them before up in Minnesota to 600 PSI. I don't know what their actual rating is, but I've safely heated them to 600 PSI without failure. So I know they're good to 600 PSI. Whether I'd run it at 500 PSI, I don't know, but I wouldn't run it over 500. I'd have a blow off at probably 510 PSI. And then on top of that, I'd have, of course, a throttler on it, so that if the pressure started getting up too high, that I would slow the water pump down, so that because it can only maintain the pressure if you feed the water in too slow to boil enough. Then obviously it's like compressing air too slow for it to spin. The water has to kind of, just like that, where you could throttle down the fan and throttle down the heat. Either way, because if it went dry on you, you could potentially melt something. Although obviously if it went dry, your motor would still slow down, because as it went boiled dry, even though for a moment it might speed up before it could get so hot it could do any damage to the metal, it would deplete all the water, and then it would no longer flow, and then the fan would quit, and therefore the fire would cool down to a naturally aspirated fire. And on top of that, you could have some kind of centrifugal gate switch or something that automatically closed off the fire or shut it down to a smolder until somebody could attend to it. But then when you get up to the ammonia system, then it's a whole different ball of wax. I don't know that I would go so far as to use this on ammonia. I have it. I am way away from that right now. I'd really rather have high pressure steel and do the other type of motor design that I've got that's a vane type motor. It'd be far superior. Stepping on paint caps. But it would actually be capable of running absolutely anything that you threw at it. I mean, 10,000 PSI at 1,000 CFM wouldn't bother it. As long as, of course, you keep your lubrication up. Well, so for now, we've got what we got, and that's all the more I'm going to do with it right now. And so we will follow up with this as we get more done with it.